Hi, this session will involve solving equations involving fractions, okay? And it can get a bit tricky at times, but we're going to start off with the basics. Now, there's two types of equations that we can have that relate to fractions, and that is the first type is where the variable is in the numerator. So we find, for example, x on top. The second type of fraction we're looking at is where the variable is in the denominator. So you have an equation and you might see x on the bottom. Okay, and we're going to work with these two types. Okay, before we start our lesson that involves fractions and equations, I want you to solve these two equations here. So we've done this in the past, just to recap and to make sure you're confident with these ones. So try them both first. Okay, so with the first one, we can see we have variables on both sides. And we know with these ones, we have to bring the variables together. Just check and see, is there anything we can simplify first? No, so we can try now and bring our y's together. Now, it is your choice what you'd want to do. You can bring this y here, the negative y, so just remember that's a negative y, to this side here, or you can bring the 5y, it's a positive, to that side here. And you'll get the same answer. So it's up to you what you choose to do. I'm going to bring the 5y to this side here. Okay, so that 5y is a positive, so to get rid of it or make it disappear, I have to do the opposite, and that is take away 5y. That will give me a 0, but of course, what I do to one side, I must do to the other. So I have minus 5y on this side. So it looks a bit messy there, so we'll just write it again. So 24, now I've got minus y minus 5y, okay? So minus y minus 5y will give me minus 6y. And that will equal, on this side, I am simply left with 0. Okay? So if you have nothing left when you do this, have questions like this, just put the 0 down there. 0 is still a number and it's there. Okay, so now I simply have to solve for y. Now be careful because I'm going to get rid of this 24 first, but don't get confused, that negative belongs to the negative 6y, okay? So that 24 is a positive 24, so the opposite of positive is to take away 24. And take away 24 on this side. So I'm left with minus 6y equals 0 take away 24 is just negative 24. Okay, and then my final step is to get rid of that negative 6. So divide by negative 6, that cancels out. Divide by negative 6, and y will equal 2 negatives, make a positive, and 24 divided by 6 is simply 4. Okay, and that was pretty straightforward. So with these ones, we know that we have to bring, in this case, the y's together, and then solve as we normally do. With our next question, this one seems more basic than the other one, and that's fine. But I want to show you two ways of doing this, okay? And it's important to be able to understand why both work. The way that you probably know how to do this is simply we first expand our brackets. Okay, I've got x on one side and I've got a 3 out here. So I'm going to expand my brackets, and that's correct. So I'm going to do it that way first. So I've got 3x plus 3, so positive, equals 9. And now I solve this equation. This 3 will go next. So I've got minus 3, so I've got 3x equals 9 minus 3 is 6. Divide by 3, and x will equal 2. So you should have had 2 for that one. But the other way of doing this is what I call the shortcut way, and I'll show you now. Now, the shortcut way, instead of expanding, instead of going 3 times x and 3 times a 1, what we can do is, we know there's a times in between the 3 and the bracket, okay? So the opposite of multiplying by 3 is I can divide by 3. And I can do this because x plus 1, they're stuck together in this bracket. And they're both going to be multiplied by the 3. The 3 is a factor of both x and 1. So if I can actually just divide the 3, and that will cancel out. But of course, I must also divide the 9 by 3. Okay? So by doing this, I now have x plus 1 equals 9 divided by 3 is 3. And then minus 1. So x will equal 3 minus 1, and we got our 2. And we've got the same answer. So whenever you see something like this, you've got a number outside a bracket, you can simplify by dividing by 3. Sometimes this won't work as well because just say 9 was 10. If I had 10 divided by 3, it won't give me an even whole number, a whole number. So just check and see whether this will actually benefit you if it will be actually quicker. In this case, it was because 3 can divide into 9 evenly. So that's an important trick to remember. With our first question, we've done ones like these ones. We can see there's a fraction, x is over 4, and x is the numerator. Okay, so we're looking at these types of questions. Now, I want to point out, in class I mentioned this negative can belong to the x or it can belong to the 4. And it works for fractions where you've just got an x on top, for example, and a 4 on the bottom, and nothing else, no brackets and so on. The next example we're doing, it won't actually work this way. But for now, you can choose. But what the best thing to do is just leave that negative with the top value. So in this case, it's x. So I'll just fix it up. Oop. Okay, so to solve this one, I'm going to multiply by 4, because we're dividing by 4, multiply by 4, that cancels out. So I now have a negative x equals 11 times 4 is simply 44. Now x isn't on its own yet, it hasn't been solved, that negative. We know mathematically what we do is that negative is really a negative 1, so we divide by negative 1, that cancels out, divide by negative 1, so x will equal a negative 44. So that should have been your answer. And the shortcut was to just bring the negative onto the other side. Now you can have a go and try this question first. Now with this one, once again, there's a negative that's sitting in the middle of this fraction here. X is on top and we've got a fraction. Now with these ones, because the 14 is being shared with the 3x as well as the 8, we can't just say this negative belongs to both the 3x and the 14, okay? These are the ones where that negative can really only belong to the top number when you've got 3x and then a minus 8 on top. And the reason is this fraction here can be written like this, 3x over 14, or a negative, and then take away, there's a takeaway, 8 over 14. That is what this fraction is actually saying to us. But because it has the same denominator, we can write it like this, 3x minus 8 over 14. And the negative can then sit in the middle. But really, the negative only belongs to the 3x here, okay? And this is because we've got two fractions, okay, that's put into under one line. And if this confuses you, don't worry. But my point is, the best thing is whenever you've got a negative in the middle, just make it belong to the top number. That's the whole point of this. Okay, to now solve this question, I'm going to get rid of the 14 first, because 14 I can see is the furthest away. So the opposite of dividing by 14 is to multiply by 14, but I'll cancel it out straight away. And of course, I must times the 2 by 14. I just squeeze it in there. So I'll stop there and write what I have left. I've got minus 3x minus 8 equals 2 times 14 leaves me with 28. Now my next thing to go would be my minus 8. So I have to plus 8 on both sides. So plus 8 and plus 8. So I'm left with minus 3x equals 28 plus 8 equals 36. Oh, sorry, I shouldn't have used yellow. It's a bit bright. I'll change my color now. So now my final step is that 3 I can see is a negative 3. So I divide by negative 3, divide by negative 3. So x will equal negative 12. And that should have been your final answer. Now the next couple of questions we're looking at, x, the variable is still in the numerator, so we are still looking at our first point, so solving equations with the variable in the numerator. We're still on this part there, but you'll notice that with these ones, there are more than one fraction. So equations with more than one fraction. So you can write this as a mini heading. And you can see how we've got one fraction on this side and another one on this side here. And these ones, there are different ways to solve these, and with this example here, I'm going to show you 2 ways. And the second way is an important skill you need to remember. So I want you to solve it how you would normally solve it, and then I'm going to show you my both ways. Okay, so the way we've learned already is, well, the x is almost by itself. It's being divided by 8, so I'll just times it by 8 and cancel out, times it by 8 on top. So I've got x equals 1 times 8 is just 8 over 2, and 8 divided by 2 leaves me with 4. So that was pretty easy. You should have had a 4 for your answer. Now, this is the one way you can do this, but now I want you to learn how to do it another way. So I'll write it up again. Now, the way I'm going to do this is important to know, especially when you have equations that can have more than 2 fractions. You can have equations with up to 10 fractions. So imagine trying to solve something like that. And this is where this method is important. And all you have to do is make the denominators of these fractions the same. So if I have a look, I've got an 8 here and a 2 on this side. Now, I know the fractions, they're on either side of each other. That's fine. It doesn't matter. Okay, imagine you've just got x over 8 plus a half. You've still got the 2 fractions. And in this equation, there's only 2 fractions. Now, I'm going to make the denominator of these 2 fractions the same. Now, if I have a look at 8 and 2, well, the lowest common multiple of 8 and 2 would be 8. So I'm going to times 2 by 4 and make it 8. And what I do to the bottom, I must do to the top. So I'm left with x over 8 equals 4 over 8. And I've made my denominators the same. And we know that a half is equivalent to 4 over 8. So we have not changed our equation. We've just made our fraction here, the fraction's equivalent. And here we've got the same denominators, and that's it. And the reason why I've done this is because whenever you have the same denominators in all of your fractions, so we've got one fraction here and one fraction there, the trick is, the shortcut is, you just cross off your 8, or your 8s. So you're left with x equals 4. And we've solved it, okay? And that's what we got before as well. So using this method is where you make your denominators the same. Now, with our next question, don't get confused. It's okay. Now, we can solve this the way you know how. And that is simply, we've got plus half, we can minus half on both sides, and we can solve it that way. But a better way, instead of having to work with fractions all the time, we can simply make our denominators the same, to the same way we did it before. So what I mean is, we've got, how many fractions do we have in this equation? We've got 1, 2, and there's also 3. 5 is really over a 1. So technically, every number can be written in fraction form. So we have 3 fractions, and that means we have 3 different denominators. Can I make all the denominators the same quite easily? Yes, I can. I'm not dealing with large numbers. I know 8, 2, and 1 can all be turned into a multiple of 8. So I'm going to make my denominators the same. And remember, what you do to the bottom, you must do to the top. So I'm going to times 2 by 4, and what I do to the bottom, I must do to the top. And on this side, I must do my 5 as well. So times by 8 and times by 8. Whoop. Okay. So by doing this, I will end up with the same denominator for all of my 3 fractions. So I've got x over 8. This hasn't changed because 8 was the highest denominator or multiple. So lowest common multiple. Plus 1 times 4 is 4, and then 2 times 4 is 8, equals 5 times 8 gives me 40 over 8. And now the fun part is, all I got to do, now that every fraction has the same denominator, I cross off the 8s. And we're done. So we have x plus 4 equals 40. And then I'll simply minus my 4 and minus my 4. That cancels out. So down here, x would equal 40 minus 4 is 36. And that is our final answer. Okay, so if you solve this one by going take away a half, and that cancelled out, and take away a half, and 5 take away half is 4.5, and so on, you would have had the same answer as x equals 36. But the skill we're learning is now, I can solve equations with fractions by making all the denominators the same. And once they're all the same, all I have to do is cross them out. And I'm left with the numerators, and I solve it. Okay, I want you to have a go at this one first by making the denominators the same. Okay, and now let's try it together. So I'm going to solve this by using that method we've just learned, making the denominators the same. So I'm going to write 3 as a fraction, so 3 over 1. And now I look at my denominators. I've got a 10, a 1, and a 5. I can see the lowest common multiple of these numbers will be 10. So I'll turn all my denominators into 10. So I've got 10 will stay there. So 1 times 10 down here, and 3 times 10. And then 5 times 2 and 1 times 2. Remember, what you do to the bottom, you must do to the top. So 2x over 10 stays the same. Plus, I now have 3 times 10 is 30 over 10 equals 1 times 2 is 2, and 5 times 2 is 10. Now that my denominators are all the same, I can do that quick shortcut and cross them all off. Okay, and I'm left with 2x plus 30 equals 2. And now to solve this, I minus 30. So I've got 2x equals 2 minus 30 will give me negative 28. Divide by 2, and I'll squeeze it here. X will equal negative 14. And that should have been your final answer. Okay, so the next type of equations we're looking at that involve fractions is where the variable is in the denominator. Okay, so these ones look a bit different to the ones we've just done. And I've just added this point here that with the first point, so we've solved equations with the variable in the numerator, and we've learned this new method where we make the denominators equal and then cross them off. So now let's move on to the second type of equations where the x, for example, may be in the denominator. Okay, if we have a look at this question here, we can see that the x is in the denominator. So it looks different, and you might think, okay, what do I do with this? Now, there's two ways of approaching this, and I'll type them up. So the two methods we can use is cross multiplication, and we've already used this before without realizing it. And method 2 is inverting. So let's try method 1. So with cross multiplication, all it means is we are multiplying our numerators with our denominators, basically. And we can use arrows to do this. So for example, we can go x times the 4 as well as 5 times the 3. And that's what we mean by cross multiplication. Okay, see how it makes a cross? So if I go x times 4, I will have 4x on this side, and then 5 times 3 is 15. And now if you don't like having x on this side here, you can rewrite it as 4x equals 15. We haven't changed anything. We've just rewritten it so x is on the left side. And now divide by 4, cross that off, divide by 4. So x is now an improper fraction. So 4 into 15 goes 3 times, remainder 3/4. So 3.75. And that's it. So with this method, you can use the cross multiplication where we just simply times by x on top and then times by the 5 as well. The other way of doing this is called inverting. So if I just write it up again. Now, inverting means to basically swap each fraction. Just like if we were dividing fractions, you have to flip the fraction. We're doing the exact same thing. But what you do to one side of the equation, you must do to the other side. So to invert this, all I'll do is go with my 3 over x. I'll now have x over 3. And now x is on top, but I must do the same thing to this side here. Okay? And I've achieved my goal. X is now on top. That's the whole point of this. And now to solve this, I'll simply go, okay, well, my next step is to times by 3. That cancels out, times by 3. X is now by itself. I've achieved my goal. And then 5 times 3 is 15 over 4. And once again, we get 3 3/4. Okay? So there are two options you can choose. It's important to see how both of them work and to understand how to use both of them because these are skills that you'll be using in other topics in the future. So let's try some more questions. Okay, I want you to try this question using both methods. Okay, try it first. So I want you to use, if you haven't written it down, make sure you write these methods down, to use the cross multiplication method and also by inverting. And we'll do both right now. So cross multiplication simply means I times by x and times by 7. So I can use arrows to help me. You don't need to, but you can. That times that and that times that. So I now have 5 times 7 equals 2 times x. So I've got 30 equals 2x. Oh, sorry, 35 equals 2x. I'll just fix that. Now, I don't like x on my right-hand side, so I'm going to rewrite it as 2x equals 35. I know I haven't changed anything. And then divide by 2, that cancels out, divide by 2. So x will equal 2 into 35, well, 17 plus 17 is 34. So 17, remainder 1/2. So you should have had 17.5. That's using cross multiplication. And now let's use the inverting method. And we should get the same answer. Okay, so to invert, so we are inverting with this method. So basically, let's flip. So we have x over 5 on that side equals 7 over 2. And I've achieved my goal. X is now on top. Okay, that's my first step. And now I simply get rid of the 5. So times by 5, that cancels out. Times by 5 on top. So x will equal 7 times 5 is 35 over 2. I've got the same thing. So x will equal 17 and a half. Okay, and that's it. So you've learned both methods. So whenever you see questions that you see the variable on the bottom, you can use either one, inverting or cross multiplication, where the x ends up on top in both ways. Okay, so just to make sure you're confident with this lesson, can you try these 2 practice questions? I've put the answers here for you, so that's what I got when I solved them, and hopefully you get the same thing. Thank you.